Welcome to The Explainer. Today, we're unpacking a really fascinating collaboration that brings together the high-stakes world of Wall Street and the absolute bleeding edge of artificial intelligence. We're looking at some joint research from Bridgewater AI Labs and Thinking Machines. And they're tackling a problem that is literally plaguing almost every major investment firm right now. How in the world do we teach an AI to actually think like an expert investor?
So let's dive right into this, because the premise here is a classic David versus Goliath story. On one side, we have those massive, multi-billion-dollar generalized AI models that have completely taken the world by storm. You know the ones. On the other side, a much smaller, highly customized model trained specifically for the financial trenches. We're going to explore whether this custom-built David can actually outsmart the absolute giants of the tech world in a space where millions of dollars are on the line every single day. Section 1. The Wall Street data problem, and why finding alpha is harder than ever. To really understand why this matters, we first need to understand the battlefield itself. Today, investors are just absolutely drowning in public information. I'm talking endless news feeds, central bank updates, incredibly long email chains. And this brings us to a really foundational quote from the Thinking Machines lab. They say outperforming the market is hard. When every investor has access to the same sources of public information, alpha must come from unique insight built on taste and judgment. See, reading the data isn't the hard part anymore. Computers can read millions of pages in a second. The real work is finding that subtle human intuition, which, as it turns out, is surprisingly difficult to teach a machine. To ground this idea, the researchers focused on 6 critical financial tasks. Now, these might look pretty mundane at first glance. Things like determining if a financial article is actually relevant to a C-suite executive, or trying to figure out where the useless boilerplate text ends and the actual insights begin in a massive email chain. But here's the thing. These are the essential daily triage tasks. If you can automate these accurately, you free up a massive amount of cognitive load for human decision-making. Section 2. When giant AI models fail, and the limits of generalized intelligence. So naturally, the first instinct is just to throw the biggest, smartest AI models at these tasks, right? Well, let's see what happens. Take a look at these 2 headlines. One is about former President Trump insisting Greenland is his. The other is about U.S. stocks dropping sharply after Trump threatens new China tariffs. Both of these touch on politics and global news. But to a macroeconomic investor, the Greenland story is completely irrelevant to the markets, while that China tariff story is absolutely critical. For a human expert, making that distinction takes a microsecond. But generalized AI models really struggle to articulate this highly specific boundary of professional taste. And the data reveals exactly how much they struggled. When given a basic, naive prompt to perform those 6 tasks, massive models like Gemini, Claude, and GPT averaged roughly a 50% accuracy rate. I mean, that's basically a coin flip. Even when human experts heavily engineered the prompts, the accuracy only bumped up into the mid-70s. And that is a huge problem, because it still falls short of the critical 80% accuracy mark. Below that 80% threshold, human investors simply won't trust an automated system in their daily workflow, period. Now, you might be thinking, well, won't the next version of these giant models just fix this organically? Actually, the data says no. The research highlights a pretty severe wall of diminishing returns. For instance, upgrading from GPT 5.2 to GPT 5.4 costs 43% more, but it only delivers a marginal, tiny increase in accuracy for these very specific financial judgments. So simply throwing more money at bigger, newer, generalized models doesn't actually solve the core problem of expert taste. Section 3. The need for expert data and building the foundation for custom AI. This wall of diminishing returns forces a massive pivot in strategy. If the generalist can't do it, you have to build a specialist. But the first hurdle there is data. You absolutely cannot train an AI to have expert judgment without expert data. The researchers actually tried buying datasets from vendors who used non-expert labelers first, and it failed completely. When they checked the AI's reasoning traces, they realized the non-expert humans were just labeling the financial data incorrectly. The nuance was completely lost on them. But here's the catch. Having top-tier Wall Street investors sit around labeling thousands of documents is incredibly expensive. So the researchers engineered this elegant verification scheme. First, they trained a model on that cheaper, non-expert data. Second, they tested the model on that exact same data. And third, this is the clever part, they only routed the contested examples to human experts. If the model disagreed with the non-expert label, it meant the example was genuinely tricky or the original label was just flat out wrong. This injected expert taste exactly where it was needed without breaking the bank.
Section 4. The Custom Training Recipe and How to Build a Giant Slayer. Okay, so with clean data in hand, they used the Tanker platform to rapidly experiment without having to worry about complex infrastructure. They started with an open-weight model called Quen. Their baseline approach was just standard fine-tuning, using mathematical techniques like GRPO to help the model weigh important data more heavily. And this instantly yielded a massive performance jump compared to the base model. But it still hovered just under that magical 80% trust threshold. They needed a special recipe to push it over the edge.
This is where the engineering gets really cool. They introduced 3 key training modifications. First up, interleaved batching. So instead of mixing all the tasks together randomly, they interleaved them round-robin style, which boosted accuracy by over 12%. Next, they swapped their loss function for something called CISPO with asymmetric clipping. Essentially, it's a specialized penalty system that guides the AI's learning much more strictly, and that gave them another 10% bump. And finally, they used on-policy distillation. Let's unpack that last one, on-policy distillation, or OPD, for just a second. This is a technique where the AI student is penalized if its answers drift too far away from a teacher model's distribution. Why does this matter? Well, the researchers ensured that a model checkpoint was only ever promoted to become the new teacher if it hit a brand new high score in validation accuracy. So this guarantees the model is always learning toward a steadily improving standard and never backsliding toward a weaker version of itself.
Section 5. The David vs. Goliath Results and the Ultimate Wall Street Showdown. All right, they have their expert data, they have their optimized training recipe. How did this custom Quen model actually stack up against the multi-billion-dollar giants? The results are incredibly revealing. Look at this breakdown. The custom model achieved an average accuracy of 84.7%, smashing right through that investor trust threshold. Meanwhile, Claude Opus and GPT 5.5 remain stuck below 80%. When you do the math, the custom trained model makes roughly 30% fewer mistakes than the absolute best frontier model they evaluated. It is objectively better at the job. But the crucial point here isn't just that it's smarter, it's the economics of the victory. Because the custom model is physically smaller and incredibly focused. It is 13.8 times cheaper to run per task than the generalized giants. 13.8 times! You are getting far higher accuracy at a tiny fraction of the operating cost.
Section 6. The Future of AI and Differentiated Intelligence.
So, what does this all mean for the future of AI, not just on Wall Street, but everywhere? The Bridgewater and Thinking Machines teams call this the era of differentiated intelligence. We've spent the last few years totally obsessed with the idea that AI models just need to get bigger and read the entire internet. But this research proves a future of differentiated intelligence is already here. It's a future where custom models, finely tuned to the proprietary needs and expert judgments of an individual organization, actually outperform generalized frontier models. We are moving from an era of generalized AI-sized to an era of specialized AI taste. It's a fundamental shift in how we think about automation and expertise. So I'll leave you with this to chew on. As AI shifts from simply getting bigger to getting wildly more specialized, what high-stakes, mundane, yet judgment-heavy task in your own industry is just waiting for its own custom David? Thank you so much for joining me on this explainer. Keep asking great questions, and I'll see you next time.